Welcome back, aliens. My name is Naveen Reddy and let's continue with this series on blockchain. In this video, we'll talk about digital signature. Why do we need it? So let's go back to the previous video where we have talked about 4 problems on the network. The first one was confidentiality, second one was integrity, third one was non-repudiation, and fourth one is authentication. So we have talked about confidentiality, right? How do we achieve that? With the help of cryptography, of course. What we do is we use a receiver's public key to encrypt the message, and then the moment this message received at the receiver end, the receiver will decrypt the message with the help of his own private key, and that's how it works. And no one else can actually decrypt the message because no one has the receiver's private key. So that works, right? We have achieved confidentiality. What about authentication? How do we achieve that? And that's where we have a concept of digital signature. So let's imagine we have multiple nodes on this network, and one of them is A and the other one is B. And B has received a packet or a message by saying, let's meet at 6 p.m. And packet claims that this is coming from node A. And this is where the problem starts, How can you be sure that this packet came from node A? And how node A can say, hey, I have sent that message? So to solve this problem, in real world as well, what we do when we write a letter, we also sign the letter, right? That's your signature, which specifies that this letter has been sent by you or written by you. How can we do that in the virtual world? Of course, we cannot use a pen drive, right? And that's where we have to use a digital signature. How can we do that? So let's imagine we have 2 keys, right? So everyone will have 2 keys, a private key and a public key. If I want to send a message, so let's say A want to send a message to B, and the message is, let's meet at 6 p.m. Now, before sending that message, what if A will encrypt the message with the help of A's private key, and then this message goes to the B, and B is able to decrypt it with A's public key. But then hold on, A's public key will be available to everyone, right? That's the case. We are not trying to achieve confidentiality here. We are trying to achieve signature. The moment A is able to sign the message by his own private key and it is decrypted by A's public key on the B's end, now B is sure that this message is coming from A because this message was able to decrypt with the help of A's public key. And the only way you can do that is if this message has been encrypted by A's private key. And now we have achieved authentication, right? But then we are losing confidentiality, right? How can we achieve that? So what we normally do is, from the A side itself, so before sending the message, A first will encrypt the message using A's private key. And then the same packet will be again encrypted with the help of B's public key. So we have double encryption. We're using B's public key and then A's private key. When B received that packet, it will first decrypt the message with the help of B's private key, and then it will again decrypt the message using A's public key. And that's done, right? Now we got a message. So we have achieved 2 things here, confidentiality, and second one is authentication. And that's how it works. So even if you have C in between, C cannot decrypt the message because it is encrypted with the help of a B's public key, right? And that's how we achieve signature. I hope you enjoyed this video. Let me know in the comment section and do subscribe for further videos. Bye-bye.